Hi, this is an example problem from chapter 11 that has to do with the change in pressure with depth in a static fluid. Pause for a moment and read the question. So we're asked to solve for the gauge pressure and the absolute pressure at points A and B in the freshwater lake. And so we can see both those points here, A and B. Now the important thing to consider whenever you're dealing with a question about the change in pressure in a static fluid like this is that you want to consider the entire fluid as a single continuous body of fluid. And so if you kind of see this fluid here, it always finds its own level, right? Here's the level surface of that fluid. And all of the points there below it are going to be measured with respect to that same surface. So if we look, for example, at the line that goes through A and B here, that line, it is the same distance below the surface, 5.5 meters depth H below the surface. So it's going to have the same pressure for A and B. This little spot over here doesn't matter. That's not the way it works. All right, so the equation that we're going to use that tells us how the pressure changes, delta P, when you go a certain depth into a fluid, it's equal to the density of the fluid, the gravitational constant, multiplied by how far down you go in the fluid. Now this delta P is typically thought of a pressure final minus pressure initial. We could think of it like that. And again, we're just going to write these, right? So we're looking at the difference between 2 points. Now in this case, we're going to measure this with respect to the surface. So the very top point here, where we begin, that's our P initial. And notice as you go down, the pressure is going to increase. And so down at this level, the red line, we've got P final, or just P, I'm going to write it. Now, depending on what we want to call these things, right? If I want to just know what the pressure is due to the water alone, we call that the gauge pressure. Because if I used a measuring device, which we call a gauge, if I used a gauge to measure the pressure of the water alone, I would have the value of the water at the top as being 0. And as we went further down, it would increase and increase, right? That would be the pressure just due to the water. So for the gauge pressure, we're going to set this thing equal to 0, and then we're going to go ahead and calculate what's the pressure at that further spot, A or B, down below the surface, a distance 5.5 meters. Well, density of fresh water is 1,000 kilograms per meter cubed, and the gravitational constant 9.8 meters per second squared, and the height below the surface in this case, 5.5 meters. If we calculate that pressure, we'll get a value of 53,900. And what are the SI units of pressure? Well, we know what that's equal to. That's equal to pascals. What is a pascal? Remember, a pascal is equal to a Newton per meter squared. And now that is your gauge pressure right here. This is the gauge pressure, because it is the pressure down at the level AB only due to the weight of the water that is pressing down on the area down at that level. So this is the gauge pressure. It's the pressure just due to the water. Let's check out the units real quick for a second here. So we know that pascals is the SI unit, which is a Newton per meter squared. Let's check out our units and see that that ends up getting what we want. So we've got a kilogram per meter cubed times meter per second squared times another meter. Let me cancel out one of those meters in the meters cubed. And if we go and now and rearrange a little bit, right, I can go ahead and take a kilogram meter second squared, right? Those are these guys right here. And then I've got also, I'm dividing still by 1 over meter squared, right? So if we look at this guy right here, That's a Newton. So we do end up with, as we said, Newton per meter squared. Good. All right. We figured out the gauge pressure. Let's figure out the absolute pressure. If we use the absolute pressure, not only do we have a bunch of water here that is weighing down on this region below, we've also got up here a bunch of air that is also pushing down, contributing to the pressure. In this case, if I want to calculate the absolute pressure, I should call this position here, instead of 0, we should start at an initial position, initial pressure equal to atmospheric pressure. And so essentially we could do it a couple ways. We could say, okay, P minus P0, same equation, rho GH. But now I'm going to use the starting point here. This is going to be atmospheric pressure. So P minus P atmospheric is equal to rho GH. And finally, we can see that now the pressure, this is going to be our absolute pressure because we're including the pressure due to the air and the water above those points. Absolute pressure, it's going to be equal to rho GH plus whatever the atmospheric pressure of the air is. In other words, this was our original pressure right here, right? This is the gauge pressure, which I just called P, or we could call it PG for P gauge. Notice that absolute pressure, if you have a gauge pressure, you just need to add the additional atmospheric pressure to get the absolute pressure. So let's go ahead and do that here. The absolute pressure, it's going to be equal to what we just measured, P, or P gauge if we want to call it that. We'll move that over there. I'm going to need to add the atmospheric pressure to it. Now, the atmospheric pressure we're told here is equal to 0.98 atmospheres, right? But those aren't the units that we want. We're going to have to convert that 0.98 atmospheres into pascals. And let's go ahead and look at a conversion factor. Here it is, 1 atmosphere, 1.013 times 10 to the 5th pascals. That's our conversion factor. So 1 atmosphere, 1.013 times 10 to the 5th pascals. And when we solve for that, we get a number, 99,274 pascals, as we cancel out the atmospheres there. Good. So that's the prevailing atmospheric pressure here. So to get the absolute pressure, then we're going to go add that. P absolute is equal to the gauge pressure, 53,900 pascals, plus the atmospheric pressure, 999,274 pascals. And finally, when we put those two numbers together to get the absolute pressure at points A and B, that's going to be 153,174 pascals. And of course, we can round more if we like. That there is our absolute pressure. And again, the gauge pressure, that is just the pressure due to the water weighing down above the points A and B, whereas the absolute pressure, that is the greater amount of pressure because it includes the pressure due to the air weighing down from the atmosphere as well as the water weighing down at the level of points A and B.